Hi, I'm Isa Sapkuda. This is my artificial intelligence coursework, a hybrid credit risk assessment system. The problem I'm solving is credit risk assessment given a loan applicant's financial profile, deciding whether they're good or a bad lending risk. The most systems solve this with a machine learning, but that has a real weaknesses. It's a black box. We got a decision with no explanation, which is a serious problem in domain the EU AI Act classifies as high risk. So instead, I built a hybrid system combining a rule-based expert system with the fuzzy logic, no machine learning at all. This lets the system explain exactly why it made a decision, not just what the decision was. Here's the system architecture. Applicant data goes through two parallel components, a rule engine and the fuzzy interface engine. The rule engine use the handwritten if then rule. For example, if someone is unemployed, that add risks. It's a simple and fully transparent. The fuzzy engine handles reasoning under uncertainty. Instead of forcing income into a hard low or high category, it lets a value belongs to multiple categories at once by degree, which is more like how a real underwriter thinks about a borderline case. So here's what that looks like concretely. These are the fuzzy membership score for income, debt ratio, and credit history. Now notice how categories overlap rather than having a hard cutoff line. This is a rule engine. Each rule is a condition and a weight. For example, three or more existing credit line adds 0.20 to the risk score. There are seven rules total covering things like employment status, role size, and savings. Next is the fuzzy engine. Here I've defined membership functions for income, debt ratio, and credit history quality. The system has evaluated all the 25 possible rules combinations. The process follows three steps. First, it fuzzifies the input. Then it evaluates the fuzzy rules. Finally, it defuzzifies the result back into a single numerical rig score. Finally, this file combines both output. Right now, the final score is calculating using weight sum. 60% comes from the fuzzy engine and 40% comes from the rule engine. During testing, this weighting produced the best balance between accuracy and recall. Right now, the final score is calculating using weight sum. 60% come from fuzzy engine and 40% come from rule engine. Let's actually run the system. I'll enter a high risk profile, unemployed, no checking amounts, large loan. And there it is, combined risk score of 0.866 high risk. And importantly, it tells us exactly why five rules fired, including unemployed, the large loan relative incomes, and this is the explainability piece that a black box model couldn't give you. Now I'll enter the input of low risk profile. And there it is, combined low risk of zero point 0.5. I tested four configurations against a held out set of 200 applicants, rules alone, fuzzy alone, and the hybrid at two different weightings. The rule engine got the highest accuracy, 65%, but its recall was terrible, only 13%. It missed most of the genuinely bad drugs applicant, which is costliest mistake a lender can make. The fuzzy engine flipped that 97% recall but only 30% accuracy. It was overly cautious, rejecting a lot of good applicants too. The hybrid ones, I reweighted it towards the fuzzy layer, improved F1 score from 0.24 to 0.31. Better balance through it, it didn't fully solve the trade off. This chart shows that visually, no single configuration wins across every matrix. Two legal frameworks matter here. The EU AI Act classifies credit scoring as a high risk requiring transparency and human oversight, which is exactly why this system explains its reasoning instead of giving a bare decision. GDPR Article 22 also gives people the right to human interventions in automated decisions like this. Beyond regulation, the dataset itself has documented bias. I deliberately excluded sex and foreign worker status from the decision logic, but that's a partial fix, since other features can still correlate with those attributes indirectly. There's also a human factor risk, automation bias. If a loan officer trusts the rule engines output blindly, that approve a lot of bad loans. Since we saw it miss 87% of genuinely risk applicant in testing, explainability helps here, but it's not complete solution. Showing which rules fire doesn't guarantee the reasoning is actually sound. Going forward, the two clearest improvement could be calibrating the rule weights against the real data instead of hand assigned values, and building a proper fairness audit that checks the approval rates across demographic subgroups. That's my project, a hybrid rule based and a fuzzy logic system for credit risk assessment, prioritizing explainability alongside accuracy.